For this third example, I'm going to solve the system equations using the addition method again. On this example, it's a little different because when I look at the two equations, they are not lined up. I have just a 5x on the left side of the first equation, and I have a 3x minus 5y on the left side of the second equation. I want to get them lined up before I start. So I'm going to go ahead and rearrange this top equation. So it was 5x equals 2y minus 4. I want to get the y term over on the left-hand side, so I subtract 2y from both sides and end up with 5x minus 2y equals negative 4. So this is the same equation, an equivalent equation, just rewritten. And now when I write the second equation underneath it, 3x minus 5y equals 6, I have everything lining up, the x's, the y's, the equal sign, and the constants. So now I'm ready to start using the addition method. And again, like the last two examples we've done, there is not a constant that I can multiply either of the equations by that would set me up for my elimination. So I'm going to have to actually change both equations. So I can either focus on the x's and look for a common multiple of the x coefficients, which would be 15. Or I can focus on the y's and look for a common multiple of their coefficients, which in this case would be 10. One doesn't seem especially better than the other. I think I'll go ahead and focus on the y's this time, just because we've done the x's for the last few. I know that if I multiply the top equation by 5, I'll get a negative 10y. So I'd want to multiply the bottom equation by a negative 2 so I could get a positive 10y. Since they start out the same sign, one of my constants I multiply with has to be a negative. Okay, so I will do that. I'm going to multiply the top equation by 5 and the bottom equation by negative 2. And again, I am really multiplying each side of the equation by that 5. So I have 5 times 5x, 25x, minus 10y equals negative 20. And for the second equivalent equation, I have negative times a positive is a negative 6x. Negative times negative is a positive 10y equals negative 12. So I've set it up so I have my y terms have the exact same numerical coefficient but with different signs, so they add to 0 and eliminate. Then I have 25x minus 6x is a positive 19x. Negative 20 plus negative 12 is negative 32. And to solve for x, I divide by 19. So I get that fraction, negative 32/19. And I could check on my calculator to see if that fraction divided out nicely. So if I put in negative 32 divided by 19, no, it goes to kind of a long decimal here. I'd have to round it, and I don't want to round. I want an exact value, so I'm going to go ahead and work with that negative 32/19. So I'll put that in. That's the x value of my solution. So now I still need to go back and find the y. And it's not really difficult to do that if you're using a graphing calculator because we can handle fractions easily. So I go back and I take my original equation, 5x equals 2y minus 4. And then for the x, I'm substituting this value, and then I'll solve for the y and find out the corresponding y. So I have 5 times negative 32/19 equals 2y minus 4. And I'll just do that right on my calculator. Okay, so I'll take 5 times negative 32 divided by 19. Again, the fractions in the parentheses. Hit enter. It'll give me the decimal approximation, so I'll hit math, and then I hit enter to choose change to fraction, and I hit enter again to complete that. So I get negative 160/19. Okay. On the right-hand side of my equation, I still have equals 2y minus 4. So to solve for y, I'd add 4 to both sides. So now to this answer, since it's the last thing that's there, all I have to do is push the plus button to show I'm adding, and it will say answer, meaning it's taking that answer and adding 4. Then I can hit enter again, and again I can hit math, and then push enter for change to fraction, push enter again to do it, and I get negative 84/19. So I have negative 84/19 equals, on this side I just have 2y. So my last step would divide both sides by 2 to get my value for y. So I'm going to divide by, just push divide by 2. Again, I have the decimal form, and I want to get the exact fractional form, so I go to Math, change to fraction, change. Negative 42/19. So now I have my y value to put in, negative 42/19. And that was my solution, and this one seems like a really good one to double check to me. So I'm going to take the equation that I did not just use, the second equation, and do a check. So for this equation I have 3x minus 5y equals 6, and I'm going to substitute in this point and make sure it is truly a solution to that equation as well. So I have 3 times, and my x is negative 32/19 minus 5 times, and in for y, negative 42/19. And I'm hoping when I do that, I'll get out 6. So this left-hand side, I can do that whole thing right on my calculator. So I'm going to clear out, and I have 3 times, parentheses, negative 32 divided by 19. 3 times negative 32/19 minus 5 times negative 42 divided by 19. Okay, so 3 times negative 32/19 minus 5 times negative 42/19. I'll just hit enter, and I'm hoping it's going to give me a 6. Yay, it did, 6. So both sides were equal, so that was a check. So even though that answer doesn't have nice whole numbers, I feel confident that that point is the solution to that system of equations, and if I graph those two equations, this would be the point where they intersected.